Hello? Can you hear me? Okay.
Come on.
Okay, we're ready to teach. Okay, so thank you all for sticking through the intermission. My name is Whatamerger Jr. This is my third time doing the news, and this is my third partner, so I think I might smell or something. But I'm happy to reintroduce It's a Trappist.
You get to hear me talk again. I'm so glad to be here.
Aw.
This is
He's my best friend.
It's an interesting energy. We've known each other for a very long time.
Yeah. Get ready. Okay, you go first.
Do I have to press the thingy?
We're new. So.
Yeah, this is something. Oh, boy. So we're starting off with a doozy on this one. You've probably all heard about this if you've seen any sort of astronomy news recently, but two different teams used the Hubble Space Telescope to discover water in the atmosphere of a habitable zone, key habitable zone, not habitable, planet. So K2-18b, which is shown in this artist's illustration here, is a planet that was discovered by the Kepler spacecraft transiting its host star, which is an M dwarf, a really small star, every about 30 days, right? So it's a lot closer to its host star, but because its host star is so much cooler than the sun, it actually receives the same amount of starlight as Earth does, right? So that actually means it would have the same temperature, possibly, depending on its atmosphere, which could mean that liquid water could exist on it. So two separate teams, one led by Bjorn Benneke at the University of Montreal and one led by Angelos Tsiaras at University College London, used Hubble Space Telescope data that peered through K2-18b's atmosphere, saw where it was blocking light from its host star, and were able to conclude that water vapor existed in its atmosphere, which is the first time that a planet in the habitable zone and a planet of this size has been found to have water. But there's been some controversy. The first round of press called this a super Earth, implying that it's like Earth but large. That's not true. It's actually a lot more like Neptune. So it has no surface, which is bad for life unless you're Carl Sagan.
No life.
And you can publish a paper about balloon creatures. Yes, he did do that. Yes, you could look it up. Yes, he was under the influence of something. So while this discovery might not, achieve what you hoped it would achieve in terms of life outside of our solar system, it's really promising for being able to detect water on small planets in the habitable zone of their host stars with telescopes and current generation instrumentation moving forward. So pretty cool. Maybe not as cool as you thought, but still really cool, I think.
Sounds like a game of Clue on the planet with the telescope. That's all I got. I lost it.
That was a great one. You didn't want to give a perpetrator?
K2. Go K2.
Hubble.
Okay, number 2. Astro Cement. So, can you guys actually hear me? It sounds like it's not on. Is it on? Okay, great.
I think it's just quieter than mine.
Okay.
So you gotta shout.
Cement. So for nearly 5,000 years, humans have used the ugliest possible construction material to build the urban jungles that we know and love, concrete.
But it works.
It really does. But I guess the monstrosity of the Hoover Dam just simply was not enough cement for humans because we've now moved on to the final frontier, which is space cement. So concrete is a mixture of sand, gravel, and rock, which is mixed with a cement powder slurry. And then that is mixed with water. And as it dries, it creates a crystallized microstructure that is remarkably durable, as we all know. So it's cheap, it's strong, and it's an excellent shield against extreme heat and radiation, making it a great candidate to build Moon City. So NASA is thus in charge of the microgravity investigation of cement solidification, or MIX, which is an experiment.
Really?
I know. Mixed cement, which is an experiment designed to investigate how concrete settles in space. So in a paper published in the Frontiers in Materials this week, assistant professor at the Penn State College of Engineering, Alexandra Radlinska, says that astronauts have successfully mixed cement samples aboard the International Space Station, which is what you see here. So the astronauts were sent to the ISS with pouches of tricalcium silicate, hydrated lime, and distilled water, which were then mixed and allowed to harden for 42 days in a process called hydration. So when this is done on Earth, the concrete typically settles into a layered structure at the microscopic level, and that's because gravity causes sedimentation. The end result in space was, in fact, hardened cement, but in the low-gravity environment, the concrete settled into a uniform density but extremely porous state. So the uniform density keeps the entire structure equally strong, but the porosity significantly weakens it. So Astro cement is not yet concrete.
Boo.
I'm not done.
Oh, do not encourage that, please.
Professor Redlinska's new idea is to use lunar regolith, or moon dust, in the mixing procedure because the jagged dust grains might actually solve the porosity problem. So stay tuned for our evil plans to colonize the moon and Mars. We might still die in the cold and with a completely barren atmosphere, but at least there will be some sick parking garages. So still more parking than in downtown Austin.
So say hello to our next solar system neighbor friend. About 2 years, God, that was 2 years ago. 2 years ago now, Astronomy News was taken by storm with the discovery of the first interstellar object found in our solar system, the asteroid Oumuamua. And just recently, Oumuamua has a friend. We have discovered the first interstellar comet passing through our solar system. So an amateur astronomer, Gennady Borisov, actually discovered a comet now called 2I Borisov after him. Discovered this comet towards the end of August of this year. Actually, when an amateur astronomer finds an object like this, they submit coordinates, etc. And then sometimes if it seems like it might come really close to Earth and kill all of us, an alert is set off. So that alert was set off. It's not going to come and kill us. But good thing that alert went off because we've now found an interstellar comet. So what's really interesting is that actually prior to this, interstellar comets were expected to be found somewhat regularly. So when Oumuamua was discovered without any sort of cometary characteristics, that was really surprising. But now we can say that interstellar comets do exist in our solar system, and that they're most likely very common, and that we will find more of them. So Comet 2I Borisov is currently 3 AU away from the sun, traveling at 93,000 miles an hour, right, which totally indicates that it's from outside of our solar system, will pass through and leave the solar system. It'll get closest to the sun in December of this year, but still beyond the orbit of Mars. So astronomers will be observing this for many months to come to learn more about it. They've already taken a spectrum of this comet and actually have found that its composition is very, very similar to comets in our solar system, right? So hopefully they didn't screw something up and this is actually from beyond the stars. But that actually means that stellar systems beyond our own probably have very similar compositions, right? And if you've heard any comet talks here before, I know there have been a few, comets really encode the original composition of the protoplanetary disk from which Earth formed and from which we formed, right? So maybe this means that other stellar systems have the initial composition necessary to form life. And now we just hold our breaths, waiting for the inevitable slew of papers and press releases claiming that this is an alien spacecraft. It is not an alien spacecraft. No.
93,000 miles. I only have one term for that. Yeet.
You had to get one yeet in, didn't you?
I really did. So the Indian Space Research Organization has been hard at work preparing for the second Indian-run lunar exploration mission named Chandrayaan-2, which is Sanskrit for mooncraft. Chandrayaan-2 is equipped with a lander named Vikram, Sanskrit for valor, and a rover called Pragyan, Sanskrit for wisdom. It follows India's first lunar mission, Chandrayaan-1, which discovered the first traces of water ice on the moon. So the goal of this mission is to map the lunar surface to study its composition, as well as pinpoint locations and the abundance of lunar water over the course of one lunar day, or about 2 Earth weeks. So the stakes are really high for this mission, since the most recent lunar mission, which was an Israeli spacecraft named Bereshit, which is Hebrew for Kirby Queso, sadly crashed into the moon's surface.
Are you going to explain that one for people who don't know?
No.
Okay, good.
Moving on.
I didn't want you to.
If you didn't know, they tried to launch the Kirby Queso recipe onto the moon, which is exactly why it crashed. No offense. Anyways.
Kirby Queso is cursed.
It really be. So no Kirby Queso on this one. Chandrayaan-2 was launched on July 22nd, and it reached the moon's orbit on August 20th. And then on September 6th, it began its descent towards the landing site near the moon's south pole, which is the furthest south we've ever landed a lunar probe. But unfortunately, you can probably tell where the tone is going here. About 2 kilometers above the surface, the ISRO lost contact with the Vikram lander as it veered off course, and it has been silent for over 10 days now. So both the Chandrayaan orbiter as well as NASA's Lunar Reconnaissance Orbiter have been searching for Vikram. Lori Glaze, head of NASA's Planetary Science Division, said, "We believe Vikram made a harder landing than they desired." I think that's a sentence I should keep in mind for auto insurance purposes. It looks like you totaled your car. Well, it was a harder break than I desired. So anyways, according to Dr. K. Sivan, the chairman of ISRO, the orbiter has caught sight of the lander, but it is unclear how bad the damage is. Attempts to communicate with Vikram will continue until September 21st, at which point we may need to say our last goodbyes. However, all is not lost. The Chandrayaan orbiter itself was launched into orbit so successfully that ISRO expects it to be operational for 7 years instead of the proposed 1. So the orbiter camera has the highest resolution camera that any lunar orbiter has ever had. So we will still be able to collect information on lunar topography, mineralogy, elemental abundance, and the lunar exosphere. So with our fancy concrete parking garages, we might still be able to build Moon City.
So I know the end of this summer has been terrible, and you're all really sweaty, but it could be a lot worse. So a team led by Laura Kreidberg at Harvard University used the Spitzer Infrared Space Telescope to measure the temperature and atmosphere of a close-in rocky planet for the first time using such observing techniques. So this was around the planet LHS 3844b, which was only just discovered last year by the TESS satellite mission, if you've heard of that. So this is a completely new exoplanet, and already tons of science is being done with it. So this planet orbits its host star every 11 hours, meaning it's extremely close to its host star. And also it means that it's tidally locked. So it's like the moon in that it has a permanent day side and a permanent night side. So you can imagine that day side is terrible. So what Laura Kreidberg and her team did was use the Spitzer Space Telescope to look at the phase curve in the infrared of this planet. Basically, you can measure how bright the planet is as it goes around its orbit of the star and turn that into a temperature map of the planet's surface. Depending on how the temperature map looks, you can determine if there's an atmosphere, basically from atmospheric circulation. More or less, is the hottest part of the planet directly under its star or not. And it turns out it is. This planet is very hot at a nice 1410 degrees Fahrenheit. Yikes. And it actually has absolutely no atmosphere. So the observations rule out any significant atmosphere, and any smaller atmosphere wouldn't be stable for a planet orbiting this close to its host star. So this isn't necessarily terribly surprising for a planet so close to its host star, but this is still the first observational confirmation of this. Using their measurements, they were also actually able to determine the composition of this planet's surface, which I think is pretty wild, considering it's so far away. And it actually looks like the moon. Its surface is some sort of basalt, like the dark maria on the surface of the moon, those ancient basalt flows. And so this is a really fascinating discovery and really important for our understanding of how exoplanet atmospheres operate. But it's a little sad as these small stars, like the one LHS 3844b is orbiting, are the most common. So they have the most planets, but it's very possible that planets in the habitable zone around these stars have no atmosphere, and without an atmosphere, good luck. We would die.
Oh, man.
Sorry.
One more story about neutron stars. So you heard Andrew talk before a little bit about pulsars. So if you've ever been nervous to step on the scale after eating too much, remember that at least probably no one has ever described you as too massive to exist. Because you're probably not 2.17 times the mass of the sun.
I don't know about that.
So astronomers recently used the Green Bank Observatory, which is a radio telescope in a hellish, desolate part of West Virginia with such little contact to the outside world that you might call it the Vikram Moonlander.
Are there any West Virginians in the audience?
No, they can't leave.
Please throw a tomato at her.
So they used the GBT, the Great Big Telescope, to detect the most massive neutron star ever found, and it tests the theoretical mass limit for how star big can be before it becomes a black hole. So people love to describe neutron stars with some ridiculous ratio of their extreme density to their very small sizes. So I'll give you one. One neutron star weighs approximately 2.6 times 10 to the 31 sticks of butter, or approximately one Paula Deen recipe.
No cheddar cheese in there?
No cheese, just butter. So as neutron stars begin to spin at incredible speeds, beams of radio waves are emitted from their magnetic poles. And they pass over our line of sight like a lighthouse. And they spin so regularly that they are tied with Swiss trains as the most accurate timekeepers in the universe. So searching for hiccups in the pulsar timing is a great way to search for gravitational waves, which you talked about a lot here. So combining 12 years of data from the North American Nanohertz Observatory for Gravitational Waves, or NanoGrav for not that short, this study found a neutron star white dwarf binary, which is well described by the Shapiro delay, which is where the gravity of the white dwarf warps space-time enough to cause a slight delay in the pulsar timing signature. The Shapiro delay is extremely difficult to observe because it requires basically a perfectly edge-on binary, and the mass difference has to be large enough to give you a large signal in the time delay. And here we're talking about a 10 microsecond delay. So it would be nice if the Austin buses would take note of a 10 microsecond delay being large. But anyway, in a paper in Nature Astronomy, University of Virginia grad student Thankful Cromartie describes a relativistic model which reveals a neutron star mass of a bit over 2 solar masses with a radius of 15 miles. So the typical neutron star black hole boundary is considered to be about 1.5 times the mass of the sun. So discoveries like these help to constrain theories of the neutron star equation of state. So for instance, this measurement disproves the hyperon, boson, and free quark models with nuclear density environments, obviously.
What was that accent?
Hyperon, boson, and free quark models.
What was that accent?
That's what I would sound like if I was a particle physicist.
I'm glad you're not a particle physicist.
Anyways, the paper concludes with an interesting thought. It's actually interesting to think about in the wake of so many gravitational wave discoveries. Perhaps neutron star mergers can actually create stable high-mass neutron stars. I don't have a joke. That's just cool. Stars can crash into each other and become one large superstar. That's cool. The end.
Oh, come on. There wasn't a joke?
I got nothing.
Thank you.
Thank you.